Coming to AES, the most popular and widely adopted symmetric encryption algorithm likely to be encoded nowadays in the AES system. The National Institute of Standard and Technology started development of AES in the year 1997 when it is announced the need of a successful algorithm for the data encryption standard, which was starting to become vulnerable to brute force attacks. Here in this project we will be discussing with respect to symmetric key block ciphers, where we will be talking with respect to 128 bit of data, but actually the length of AES varies with respect to rounds that we will be using, that we will be discussing further. Based on the rounds we can go for the 128 bit, 192 bit, 256 bits of key lengths. Obviously, as said earlier, it is stronger and faster than compared to previous conventional way of encoding things. AES is built on the Regender cipher developed by the two Belgian cryptographers Vincent Rijmond and John Dement. How it works? Initially 128 bit plain data, which is going to get submerged with the key size which is generated as an input, then processed with respect to AES encryption. The output of that will be 128 bit ciphertext. Now the question is how the 128 bit data, plain text, and a 128 key size, this is also an input, right? I forgot to mention a arrow mark here, is going to then process with respect to AES encryption, going to convert into 128 bit ciphertext. This is the question. This we can explain with respect to an example in the coming few moments. For the basic understanding of AES, as said earlier, the key length of the AES can last from 128 bits or 192 bits or 256 bit keys based on the number of rounds. If I am talking with respect to 10 round, then I need to go for 128 bits. If I am talking with respect to 12 rounds, then I need to go for 192 bits. If I am talking with respect to 14 rounds, then I need to go for 256 bits. With respect to this project, we will be moving with respect to 128 bits. So obviously, we are going to process total 10 rounds, starting from round 1 and so on till nothing but till round 10. Always remember, irrespective of the rounds, for every key length, we will be having one pre-round config transformation. This is a place where the key is going to get accumulated with respect to the rounds. And here is the process where the key expansion is going to get processed. So in order to understand this better, we need to first understand how this key expansion is going to happen. Second, how the rounds are going to get happen. With respect to key generation, the first process would be the finding out the route word of the last column. The second process would be the subword of this route word. The third process would be the making an XOR operation with respect to the predefined OR convertible with respect to the first column and making XOR with the subbyte value. And the last step would be the generating of a round key. With respect to round table, initially for the first time, nothing but a pre-round transformation, we are going to perform the XOR operation with the key 0 that we have generated in the earlier stage, at the key expansion stage. From the main round, which is nothing from round 1 to round 9, which will be acting as a main round. Here we are again going to perform the 4 steps. Nothing but one is with respect to subbyte, second with respect to shift rows, third with respect to mix columns, and the last with respect to add one more round key until the last but one round key till 9. Coming to the final round, nothing but the round 10, we are not going to perform this mix operation and we are going to perform everything else. Nothing but the first step would be subbyte generation, the second step would be the shift rows, and the third step would be the adding route key. Here we are now going to mix column, just make a note of that. This could be better understand with an example. So let's start with an example.